Hi, everybody. Welcome to today's live solution experience tour. My name's Francesca Baird. I'm a technical trainer here at Post-Process, and I'm going to be taking you through PolyJet and FDM soluble support removal, and then we're going to touch on surface finishing. Some things I want to cover before we get started. So Q&A will be available at the end of the session. You're going to use our chat feature to send in any questions that you might have. If we don't get to everybody's question, we do have coffee chats available, and that's a great way to get some one-on-one time and get all the information that you might need. And before we kick off the live lab tour, we are going to start with a poll to get to know you a little bit. All right, so currently, what is your biggest post-printing challenge? Is it the length to finish your parts? Are you damaging parts during post-printing? Are you having issues with the consistency of your parts when they're finished? Are you having throughput limitations, or are you experiencing another post-printing challenge? We'll pause for a moment here and let you guys all have your answers. You can just click right on your screen to submit. All right, now let's look at the results. Okay, so it looks like we are split up between the maximum. A lot of people are having a hard time with the length it takes to finish your parts, which is great because we're going to address that, as well as some throughput limitations. So I'll address all of these challenges with each of our technologies. First, we're going to get started with FDM soluble support removal. So behind me, what you're looking at is our DESI, which is our smaller unit when it comes to FDM support removal. It pairs great with the Vortex 450 and under. We also have a unit that's about twice the envelope. It pairs great with the Vortex 900. So we're going to go through a hardware, software, and chemistry overview for each one of our machines. So hardware-wise, when you start in here, you open up this door, you'll see that we have a spray manifold down on the bottom. I have a couple parts in here that I'll quickly show you before we talk about the technology. We have a lattice that has some internal geometries that are generally really challenging to finish when it comes to using a traditional submersion tank, or potentially if you're trying to manually remove those supports. A vacuum head with a lot of external features. And then finally, we have this valve part, drain the detergent out, that has different internal channels of different sizes, which are extremely challenging to finish. And then we'll talk about the accessories that help us speed up those cycle times. Just to give you a little bit of reference here, what those parts look like before. And that vacuum head. So all of these were processed in under an hour. So it's really great, especially since you guys answered that the majority of you are struggling with the length it takes to finish your parts. Generally, all of our cycle times in this machine are between 30-minute to 90-minute range. So the technology we're using in here is a spray technology, which really speeds up those FDM cycle times. Okay, so now getting into the mechanical components. If I lift up this tray here, what you're seeing here is one stationary rack that has multiple wide range dousing nozzles. So these are low pressure nozzles that are meant to really just saturate the part in the detergent. The detergent here is really doing the bulk of the work. Just that added mechanical energy of the heat as well as the pressure from the spray removes the support as it's weakened, and it really helps speed up those cycle times. So then we have a second spray rack up on the top. So in there we have three sets of manifolds, one in the front, middle, and back. In the front, they have a little bit of a more narrow spray that's going to increase the pressure and as well start to knock off those supports just a little bit more. And then in the middle, once again, we have those wide, low pressure dousing nozzles. That spray rack moves back and forth for a sweeping motion to add a little bit more agitation to help once again speed up those cycle times. If you're wondering what's on the, there we go, right side of your screen, that's the software that's running on this machine. So right now we are in our automated mode. It looks a little bit different than what you would typically see with our auto mode, When we move on to the next machine, you'll see something that, if you're familiar with our machines, looks a little bit more familiar. But you can see exactly the components that we control on the screen here. So I'm going to go and start off in manual mode and show you the levels we control we have over each one of the individual components. You can open the different solenoid valves that, oh, I can't do it because the door is open. So for safety, every time that you click to open that door, you have to click out of that alarm. You can control the valves and open them individually. You can control the pump speed, so that's going to correlate to the pressure coming out of those nozzles. And then the heater set point, this is going to be really important because we know running at those higher temperatures, generally between 140 and 160, is going to be the ideal temperature for processing those thermoplastics that are associated with FDM support removal. And then again, if you're looking over at the bottom of the screen, you can see we have individual switches for each one of the components we're using here, as well as automatic draining and filling of the machine with detergent, so the chemistry is always going to be hands-free. So moving out of our manual mode, if you look at our automated screen, typically this would be a little bit more simplified, but you really just need to pick a couple simple parameters and then just press play, and then that's automatically going to run for the time that you have allotted for it. These grayed out buttons are for saving and storing recipes. So once you've determined the best way to run a certain geometry, you could save that under a name that's indicative to either the geometry, the material, or the support material. So then you don't have to be trained exactly on how to run the machine. You can simply pull up a recipe and hit play. So now onto the chemistry side of things. If we want to roll back to the back side of the machine, as I mentioned before, the detergent is automatically dosed into the machine completely hands-free. So what you're looking at is a dosatron here that doses 90% water and then 10% of the detergent. It is in two parts. It mixes in the machine. So whenever you hit that dose button, the machine is automatically going to fill up with that detergent. It's then going to recirculate. This machine here, the Deci, runs about 20 gallons of detergent. Our larger option runs about 40 gallons of detergent. And then after that it's been saturated, you're going to either drain that into a container to be taken away as hazardous waste, depending on what you do locally, as well it could be gone down the drain, depending, once again, on your local regulation. All right, so that just about covers everything here in our FDM machine. Now we're going to swing over to our PolyJet support removal solution, and this is our Demi. So now we're going to swap over to the different software. So this is a completely different technology that utilizes different mechanical energy sources. So this is what we call a submersed vortex cavitation. So what the part is being submersed in is the detergent. The vortex comes from the strategic pumping scheme, which I'll show you by going into our manual mode and turning on that pump. You can start to see that detergent flowing. And then lastly, the cavitation comes from the ultrasonic transducer, which hopefully you can see right here, which is mounted for maximum efficiency. So rather than having support material fall onto the bottom and then the frequency of those ultrasonics being hindered, now we have them mounted on the side, so they're going to be efficient for the entire process. So once again, while you're looking at that manual mode screen, you can see how we have control over the percentage of ultrasonics that we use. So that's up to 100%. Specifically on this model, we have a maximum of 1,750 kilowatts that can come out of this machine. The temperature limit, we generally keep that 100 degrees and under for our PolyJet applications. We also have special software modes when it comes to resin removal, which is another application that runs in this machine. We also have an FDM solution that you can run in here, but we see the FDM in the spray machine really works with the maximum efficiency. When it comes to filtration in this machine, we have 3 stages of filtration to help extend the lifetime of your detergent. So we have a large debris sorter here, so large chunks of support that get broken off get stopped here. Then we have a filter screen here that can be rinsed off once after every cycle or potentially once a day that grabs the larger particulates. And then finally, we have a micron filter down below that acts to grab the smaller particulates. An example of what that filter looks like, it's a reusable stainless steel filter. And depending on what application you're running, we can change this to customize that for you to help you get the most out of your detergent. While we're down here, you can see everything is really high-grade stainless steel. Maintenance is really simple. Once you have reached the lifetime of your solution, you're just going to use these drain points to get rid of your detergent, dispose of that however you're currently disposing of your post-processing detergent, and then do a quick clean through and fill it back up again. So then an example of a part, I'll show you a quick before. So this is a spine model made with 706 supports. So it's actually running in our machine right now. If you go to our auto mode, you can see the process by selecting those recipes that I talked about over in the base. So if you go to our recipes folder, we have it saved as spine. So this part ran for 4.5 hours with a temperature limit of 110. So that's a limit. You're never going to be going over that temperature. You're going to be floating underneath it, probably give or take 10 to 5 degrees. So now we have different fixturing options for this size of a part. The basket works really well. You pull this out, you can see how there's some pretty intricate internal geometries. And to process a part like this, all we would do before just setting it in the tray and selecting the recipe, doing some bulk removal with gloves on, picking off the large pieces of support is really going to help speed along that process. So some special things when it comes to PolyJet. The difference here, this may take 20 to 30 minutes in a water jet if you're cleaning it, but the benefit of our solution is really when it comes to batching. So you're no longer going to have to spend 20 to 30 minutes on every single part. Now you can just load up the entire envelope of this machine, press play, and then go do some more value-added work. So in our auto mode, if we go outside of the recipe, we really try and simplify it. So you do have the option to go in manual mode and control the ultrasonic down to the percentage, the temperature down to the percentage, or you can just set your limit, choose your 1, 2, 3, 4, which correlates with the amount of ultrasonics you're using. So depending on what that part looks like, how fragile or robust the features are, that's going to help you choose that 1 through 4 setting. And again, we do have this process that we call ITI, which is installation, training, and integration. So we'll come on site to your location, install the machine for you, and then we're going to stay with you for the day and look at the parts that you're running through this machine. We can not only help you set up those recipes for you to recall, we're going to help you understand exactly how to use your machine best for your application. So it's already worked into your workflow prior to us leaving the site. All right, so I'm quickly just going to demonstrate exactly what running this part would look like. Put this basket down in there. Then you press play. And it's as simple as that. All right, so that just about covers our PolyJet support removal. So now we're going to move on to surface finishing. All right. So our surface finish technology is not going to be technology specific, which is really great, especially if you are running multiple technologies at your facility. You no longer are going to have to switch out either the media or the detergent. And that's because the detergent here is really working to lubricate the parts and wash away any broken down media. Put on a fresh set of gloves. So the technology we're using here is a circulating vibratory media. The media is going to act as tiny little pieces of sandpaper to help abrade the surface of your part. We get a little bit of a close-up here. So we have different sizes of this media. This is an example of one of our largest and best medias for those more robust parts. So if you're doing metal surface finishing, these are going to do a really great job of getting a good finish pretty quickly. We also have smaller porcelain media to help you achieve more of a luster or a shinier finish, depending on whatever your requirements are. Once again, our application engineers are going to make sure that this solution is designed exactly for what your needs are. So then on the chemistry side of things, we have these 3 dosing nozzles and as well a lid here that's monitored by a float sensor. And what's really great about that float sensor is that it's tied into our software. So depending on what level of dosing you choose, that level of dosing is going to be tied to whatever media you're using and how much lubrication it requires. So if we pan over to the software here, so that float switch is going to be tied into the software and let you know how long you can run on each dosing level. You'll see as we click through the different levels, that's going to start changing. So then you're never going to worry about running out of detergent and then not having the proper lubrication for finishing your part. As well, we have a sediment tank sensor that's going to let you know how long until you have to drain that out. We have options where you can automatically plumb this to just go down your standard drain, and then you can dispose of the sediment on the bottom of the tank as solid waste, so you're not going to incur any hazardous waste costs with this machine. All right, so that's about everything that I had prepared for today. So if we want to roll into some questions, you can utilize that chat function. Okay, I have a question here about finishing metal parts. So yeah, so like I said, this is not technology specific. You can finish your metals, your polymers, anything that you're doing, you can finish in this machine, again, because we aren't leveraging any chemical energy. So we're just going to change the different media and that dosing level to get you the best finish depending on what materials you're using. Thank you for the question. Okay, I have another question here regarding the pressure on our spray solution and if it's going to break the parts as they go over the chamber. So it really is more of a high volume, so you're getting a lot of that detergent in the machine at a lower pressure. So we're not trying to power wash the parts. You did see we have the level of control over the speed coming off of the pump. So we can dial that down for your more fragile geometries, or we can, if it's really robust, we can crank that up a little bit and speed up that cycle time. But once again, there's spray coming from the bottom and the top that's going to work to equal each other out. So you're really going to be able to adjust to whatever your application is. I have a question here if you can stack the parts in the spray machine. So yes, we have options. So you can stack different levels of trays within the same machine. So you could run multiple trays in one cycle. However, shadowing could become an issue depending on what those geometries look like. So it's really going to be based on what your parts look like for how many stacks of parts that you would be able to do. I have a question regarding how the chemistry does not penetrate the build material. So all of our support removal technologies are based on the build material and the support material being different materials. So our chemistry is specifically targeting the support material and going to not affect the build material so that we don't harm the integrity of that geometry. So any of your all-temp parts or breakaway supports, such as SLA, we're not going to be addressing removing those supports. The best way to reach internal geometries on ABS parts. So back in that spray machine, you saw that little black hose with the orange nozzle on it. So we've introduced different accessories to help you address those internal channels, because those are, even if the part is completely submerged in a submersion tank, still really challenging. So now we have those nozzles to directly address those internal channels, and within 10 to 20 minutes with the nozzle angled in the right way, we can clean those out. So what kind of PolyJet materials does this work on? So we've successfully removed 705 supports, 706 supports, and 707 supports. All right, so it's about 20 after now. We're going to wrap things up. I really appreciate you taking the time to come and take a tour with us. If you're wondering what you can do next, we have the ability for you to submit a benchmark. So send in your part, we can process it and let you know what results that we achieved. You can schedule a virtual tour just like this one you saw today. We can even go over your benchmark and show you exactly what process we went through. If any of your questions didn't get answered, we do have coffee chats still available for this week. If you look at the link in the chat right now, you can click any of those and see the rest of the schedule for the week. So everybody, thank you once again, and hopefully I'll see you at some events later this week.